Hello, in this video I'm going to be discussing near-end crosstalk and far-end crosstalk for when the reflection coefficient is 1. So, as we can see in equation 12.19 and 12.20, these are the near-end crosstalk and far-end crosstalk equations for when the victim line is quiet. So these are the actual equations, like derived. There's no approximations with these. So what we will do is we will look at these and we will find simpler equations for when the reflection coefficient for the load is 1. So if we look at this, well, we'll do the far end crosstalk first. So if we look at the far end crosstalk and we set the load reflection, because we are going to assume that the source reflection coefficient is 0. So what that means is that this term right here and this term right here go to 1, and this term right here go to 1/2. So if we do that and then we set the load reflection coefficient to 0, we'll find the regular equations that you can find online. So if we set the load reflection coefficient for far end crosstalk to 1, we can find that this term right here will go to 2 instead of 1, and this term right here will go to 2 instead of 1. So we know that we can double the far end crosstalk for a load reflection coefficient of 0 to get the far end crosstalk for a load reflection coefficient of 1. So I'm going to write that down. So what we will say is we will say the far end crosstalk for reflection coefficient equal to 1 will equal the far end crosstalk for the reflection coefficient, load reflection coefficient of 0 multiplied by 2. So that will be our updated equation. So for the simplified version of the far end crosstalk that you find online, you can double it if you make the reflection coefficient 1. So now we will do the near end crosstalk. So we will do the same assumption as before, stating that the source reflection coefficient is 0, and we will look at the case right here. So right here we can see that the load reflection coefficient, if it's 0, then we don't get this term right here, and we don't get this term right here, and this just goes to, these two terms go to 1. So if we realize that this term right here and this term right here is what actually, so basically if we looked at this and we just removed this, then what this equation simplifies down to is it simplifies down to the case for the far end crosstalk, but whenever the load reflection coefficient is 0. So what this says is that we can say that the near end crosstalk for reflection coefficient of 1 is equal to the near end, sorry, that's not the right symbol, the near end crosstalk whenever the load reflection coefficient is 0. And we're going to add the far end crosstalk for whenever the load reflection coefficient is 0. However, we have to notice that the length here is multiplied by 2. So we'll say that the new length is equal to 2 times the old length. And if we plug in our simplified equations, then we will find that this is equal to the far end crosstalk whenever the load reflection coefficient is 1. So we will write, and these are pretty much the simplified equations, and we can find that this guy is this guy plus this guy. So the maximum crosstalk in our system will be the far end crosstalk whenever the reflection coefficient is 1 plus the near end crosstalk whenever the reflection coefficient is 0. That's all I wanted to share.